workshop that is 5G-GROWTH, 5G-DIVE workshop with the target to present and discuss the experience from a field trial about the vertical industry. I share with you the agenda. So do you see? Okay, this workshop is organized in 3 sections in order to have some presentation from vertical point of view. We have presentation from FSEC, from NCTU and D3. Sessions 2 dedicated experience from operators and vendors. We have presentation from Nokia, Bell Labs and from Ericsson. And the third section instead present experience for small and medium enterprise. We have a presentation for Nextworks and Telcaria. And then conclude the workshop, open panel discussion with the concluding panel that remark the main highlights and main point that have been presented during the day. So I think we can start, and I remind all of you to mute during the presentation in order to avoid problem with the audio. And I give the floor directly to Carlos Bernardo for University Carlos Tercieros on Madrid for the fifth section. So please, Carlos, you can start.
Okay, thank you very much, Paula, and thank you everybody for joining today to this workshop. So the first session, as Paula introduced, is about the experience from verticals, and we're going to have two very interesting presentations. One from Paulo Paixão from FSEC on the experience that has been collected and is being collected and gained from 5GROWTH in the use of 5G for critical transportation systems. And then we'll have another presentation jointly done by E3 and NCTU from our Taiwanese colleagues on the use of 5G infrastructure to support aerial disaster relief. So I don't want to steal more time from them, so I think we can just pass the floor to Paulo Paixão. So please, the floor is yours.
Okay. Thank you.
Sorry, this is Antonio. I think for the sake of bandwidth, we can close the cameras for the people not presenting. Thank you.
Okay. Good morning. I think I am sharing my device, my screen.
Yes.
So, okay, thank you. Good morning. My name is Paulo Paixão, and I'm R&D manager at FSEC. I would like to thank to Carlos and Paula for the invitation and for the opportunity to show the achievements of 5GROWTH related to the transportation pilot. We are validating a level crossing supported by 5G technology, and I'm very excited to show the audience our results. Just a few words about FSEC. FSEC is the largest Portuguese company in the electromechanical industry sector, and the transportation business unit operates in the segments of railways, light rails, and highways. The left picture shows the FSEC campus in Oporto, in Portugal, and the right picture shows the vertical pilot site that is located in Aveiro Harbour. So in the beginning of the project, we managed a protocol with Aveiro Harbour, the board, and we got the permission to use their infrastructure to deploy and validate our pilot, a level crossing, a railway level crossing. So since the presentation is related with a critical transportation system, let me explain what is a critical system. So a safety critical system is a system.
Paolo, you are in mute. Paolo, you are in mute.
Paolo, you are muted. Paolo, you are muted, Paolo.
Sorry. Yeah, I think again. Sorry. You are listening to me now? Hello?
Yes, now yes.
Yes.
Sorry. So in the transportation systems, rail, and more specifically the rail signaling system, is a safety critical system. So therefore, we brought to 5GROWTH these vertical requirements to be validated. The purpose of our pilot, it's a vertical validation using 5G communication to support rail signaling operations, in particular to meet rail level crossing communication requirements. So the picture shows the environment related to a level crossing. You can see the road and the railway track and the equipment involved in the level crossing. And the right picture shows the Aveiro Harbor location with the train that is leaving the harbor. And you see the road, and this is the location of the level crossing. In the level crossing, typically, and the old systems without 5G technology or without wireless technology, all the equipments are connected typically by copper cable or even optical fiber cables when the long distance between the level crossing controller and the train detectors. So the idea of this project is to use the 5G technology instead of fiber or cable wires connections. Just a few seconds to speak a bit about a level crossing behavior. We see the equipments, we see the train approaching detector, and we see a train approaching the level crossing, and we see the changes in the lights and the equipments and in the bells. So the train is approaching the level crossing, start the safety operations in level crossing, and the train release the level crossing and is clear for traffic road. Okay, so as I told you before, the idea is to replace this cable connection between the detectors and the level crossing controller by 5G technology. This introduced several challenges because we must keep the same level of safety using this kind of technology. So moving from closed communications environments to open communications environments have some new constraints regarding safety protocols and security protocols. But there are several advantages using this new solution. And so let's take a look to the business requirements. So with this new technology, we can reduce the capex and reduce the system installation costs and reduce installation time and reduce cable costs and also reduce the maintenance visits. So it's in terms of installation and in terms of business indicators, it's a very, very good advantage. Regarding our requirements concerning the use case and the level crossing communication, this column shows our requirements. We have, because it's a critical system, we have huge requirements concerning reliability. The level crossing must work every time. And we have requirements concerning the latency. And we don't have big requirements concerning the bandwidth because we just need to send the information regarding the level crossing and the detectors of the presence of the train. And concerning coverage, we are looking for 2 kilometers in this Aveiro Harbor location. So here we have the architecture. So the challenge is to connect the detecting point and the level crossing controllers with the 5G technology. And this is the picture shows the diagram. We need to connect the detector to the 5G interface connected to the 5G in network infrastructure in order to have very good safety operations conditions. So this picture shows our architecture in terms of diagrams and all the layers involved in the communications. So we have here the wheel sensors to detect the train, and this information goes to the train detector cabinet that implements all the protocols in order to send the signal information. And we also need to put this information in IP to transport to in IP network using safety protocols and cybersecurity protocols over 5G infrastructure. So the challenge is to try to achieve a very good communication between the train detectors cabinets, both to the level crossing control. Okay. So going to the field, this shows the architecture and also the pictures of the system in the vertical side. In this project, the infrastructure is provided by Altis Labs. And the IT campus, meaning the building 1 and building 2, provide the components of the 5G network infrastructure. This infrastructure in the campus is connected to Aveiro Harbor. It's about 5 kilometers from the campus to the Aveiro Harbor. And the radio unit is located in the water tower, located inside the Aveiro Harbor. So you can see the radio units and antennas located in the Aveiro, the water tower of the Aveiro Harbor. Okay, the connection of Open 5G core that we are using in the project and the communication with the CU and the RU use the University of Aveiro private optical fiber infrastructure, and the CU and DU and the radio unit are connected by dedicated optical fiber from the public network, connecting the campus to the Aveiro Harbor location. So this picture represents the Aveiro Harbor. We can see here the road, the level crossing, and the track, the railway track here. The water tower is here, where we put the 5G antenna. This is the first train sensor. This is the level crossing cabinet controller, level crossing controller. This is the second train sensor. So trains arriving to the Aveiro Harbor are detected by this sensor, and when the train is leaving the harbor is detected by this sensor. Okay. So since the beginning of July, we finished deployment on the vertical side, and we start the validation campaigns in the field. So first we prove the proper behavior of the system in the lab. We're using simulators, but since July we are using the field for the validations. So we perform some static tests and we perform some dynamic tests. The idea is to prove that statically the communications is quite good, and the dynamic tests is we try to prove that we can register the CPA clients over the coverage zone. So this is the antenna for the CPE devices, the 5G CPE devices, and this is the integrations we made with the 5G interface and the processor unit. So this is just the idea of the coverage. The first train sensors is located with this distance. The level crossing is located with distances from the antenna, and the second train sensors is located here. Okay, just a picture of the hardware and pictures from the field. This is the train sensor detector cabinet. This is the same for the first and the second detector. This is the wheel sensor located in the track. This communicates directly to the cable to the sensor cabinet, and this is the picture of the track, the railway track. Oh, some other pictures of the field, the level crossing controllers cabinet, the cabinet for the 5G interface, the people working in the field. And now this is the equipment that we deploy in the field for the control of the level crossing. So we had to remove the old signals, the not just static signals, for an automatic environment. Okay, this is just for the road, and this is the bells that rings when the train arrives. So some other pictures of people working on the field, and this picture shows a very important information because we want to prove that the wireless communication works properly. And we want to prove that we have benefits by removing the cables. We use the solar energy to power up the level cross the train detector cabinet. So the communication and the communication between the cabinet and the level processor controller is always without any cable. Okay, this is the detail of the cabinet. You see here the information concerning the solar energy. This is the 5G interface, and this is the equipment with the software to detect the train. So this is pictures related to the trains that we are using for our tests. The trains belong to a private operator, Medway. This is all the different trains that we use for the tests, and this is the equipment that we install in the field. So before going to the functional tests, we perform some performance tests. And we perform some tests using a simulator. This is the test wheel sensor in order to simulate the presence of the train. And after everything is working properly, we move for the real equipment, meaning trains. So now I want to share with you some results we have in the field. We also collect this information in the lab, and now we are collecting the information directly from the field. So I told you that we need latency about 10 milliseconds. This is the measures the measurements that we got on the field. The round trip time is about 30 milliseconds, and the latency is half of this value. So in the field, we have the minimal value of latency of 15 milliseconds. That is quite good, quite good. Regarding the bandwidth, this table shows the improvement improvements concerning the bandwidth and the results. This is the collection made in the beginning of July. We have poor bit rates and a lot of failures, and now the results in the middle of October for this the communication that we need for the level crossing. We have no failures at low bandwidth, but when we use higher bandwidth, we detect some kind of errors, but at 30 megabits per second, the failures and the packet loss, it's almost nothing. So, but until the end of November, we will have some other campaigns, and we have the opportunity to have better performance on the system. Okay, just another idea of the system. This is the freight that is going to leave the harbor. Again, the sensors, and now I think I can show the results of trying. So this can be means nothing, but is the tests, the simulation tests when the train is arriving to the level crossing. So the white light means that the level crossing is free, and the red light means that the level crossing is not free for cars. This is made with the simulation, and now a real test with the trains. I see. Can show. So while the train is passing over the level crossing, the system announces that the level crossing has been forecast. I will move for the end. The train is leaving the level crossing, and now the level crossing is again free for cars. And okay, this is white again. It's protected because we are under tests. So conclusions until the moment. We deployed the system. We are achieving and collecting measurements from the field. We perform the performance tests in the field. We are now making functional tests on the system and proving that everything is working properly in the field. Very important thing of this system is the registration and the deregistration of the CPA clients in the 5G network. So we can cover distance of 1,070 meters. We can prove that we can resist and resist the CPA clients. Okay, of course, for this use case, we don't need some distance. For the first time, Efs using this kind of technology, we also the IP solution and the 5G technology is the first time we are using, and this have huge effort in terms of software and configuration to adapt the systems for this new environment. Now the system is under certification, and the performance tests and the functional tests and the detailed analysis of the event reported by the level crossing assures the proper behavior of the system. Thank you for your attention, and I'll be glad to answer your questions.
Thank you very much, Paulo. So, any questions from the audience?
Well, I would have a question.
Okay.
Is this? May I just go ahead?
Yeah, of course, of course.
Yes, yes, sure.
Okay. Is this related to this FRMCS development that we have in the railway system, or is this totally unconnected to this activity?
I'm sorry, can you repeat?
Is your project somehow related to this FRMCS, this Future Railway Mobile Communication System activities that are currently ongoing, or is it totally independent of that?
Yeah, it's totally, for the moment, it's totally independent, but we are aware of what is happening, not only with this environment, but also with the shift to rail. We are looking what is happening in the world, and we try to bring information and relating certification, safety protocols, standards, everything to we are bringing that information for the project, but for the moment is independent.
Okay, thank you.
And
Thank you.
the other
Any more questions?
So, according with the audience, I try to make a functional and mixed with the technical information, but I can explain everything in detail, not only in terms of functionally of the technology and technical information, and I'm ready for the questions.
I think your presentation was very good. So I will also encourage people, if there are questions that you have, you can also directly contact Paulo Pachao by email. I'm sure he will be glad to answer. So maybe just for the sake of time, we can move to the next presentation from our Taiwanese colleagues. So thank you very much, Paulo. And now we move to the next 5G-DIVE presentation. So the floor is yours.
Okay, thank you.
Hello, can you hear me?
Yes, loud and clear.
Yes.
Okay. You can also see the slide, right?
Yes. Okay.
Good morning, everyone. My name is Tim. Together with my colleague Samer, we're gonna bring a presentation on the end-to-end deployment of 5G-enabled edge infrastructure to support for aerial disaster relief response system. We'll be using the following outline for today. We're gonna first talk about the introduction of the disaster relief, and then follow with an overview and then highlights of the disaster relief response system. And then we're gonna explain about the disaster relief response scenario that we're gonna do for the trial, followed with the initial results that we gathered, and then concluded with the conclusion. We're gonna first start with the introduction. We're gonna first talk about the rising popularity of aerial drones in the day-to-day life in the recent years. This rise in popularity is attributed by two factors. The first one being the flexibility in the operating environments of the drone, as well as the technological advancement of the drone technology. Because of this small size and agile nature, drone has been widely used to perform a lot of tasks. It can be used to reach for remote area or area that otherwise could not be reached by ground transportation in the case where the infrastructure is damaged by a disaster, natural disaster. As for the technological advancements, recently there has been a push in the drone battery technology, GPS chips, as well as better embedded system that can be mounted on the drone. If we look at the news recently, there has also been a lot of buzz in regard to Amazon using the drone for the goods delivery, package delivery, as well as a new mode of transportation. But for today's presentation, we're going to focus our attention on the utilization of aerial drones for disaster relief mission. So combined with the AI inferencing techniques, the data gathered by the aerial drones has been utilized in combination with AI techniques to gather useful insights. This can, for example, this can be in the sense of the detection and localization of a person in need of help in a disaster-impacted area. This kind of mission for the detection and localization requires for unique requirements in the sense that it requires for high computation capability for running all of those AI techniques, followed with a high bandwidth and low latency communication to transmit all of those data collected by the drone to a compute server in a real time or in a timely manner. So with these two requirements, 5G-enabled edge come as a promising solution because by utilizing 5G, the drone will be able to transmit all of those data, video data, GPS data to the edge with a high bandwidth and low latency communication fashion. And then with the edge, it will have enough processing power to run all of those required AI inferencing in real time. With that said, we're gonna now move on with the overview of the complete system. The above is the figure for the complete end-to-end deployment of the disaster relief response system that we are using. It utilized the 5G-enabled edge as well as the enhanced with the 5G-DIVE platform to enhance the system performance. We're gonna talk more about the integration with the 5G-DIVE platform in the upcoming slides. The complete system consists of three main components. The first one being the aerial drones that is used to perform aerial scouting of an area to gather data and do some pre-processing before transmitting the data to the edge. This data, in our case, will be in the form of video data as well as GPS data. The second component being the 5G connectivity. This is what the connectivity backbone that the drone is using to transmit all of those data from the drone to the edge. In this case, we are using the 5G non-standalone setup to do the 5G connectivity. As for the edge, this is where the core network component, like the EPC and then the backbone that the drone is using to transmit all of those data from the drone to the edge. In this case, we are using the 5G non-standalone setup to do the 5G connectivity. As for the edge, this is where the core network component, like the EPC and then the IMAC is running to perform network function, as well as where the intelligent application will be running. In this case, one example will be the Eagle Eye. We'll also explain more about this in the upcoming slides. Up next is the system integration with the 5G-DIVE platform. We can see that the system is enhanced with the DAS, the ISS, as well as the bus. In our case, the DAS, we are utilizing it to perform data preprocessing as well as storage. The DAS is running on the aerial drone as well as on the edge to store all of those data. The next one being the ISS. We utilize this to perform automatic AI model training for our AI inferencing. In this case, the AI model train will do the person in need of help detection in the disaster impacted area. The third one being the bus. This is the automatic application manager that is responsible to automatically manage the lifecycle of the deployed application. In this case, the application to be managed will be the Eagle Stitch, Visualizer, as well as Eagle Eye, and the drone navigation server. This is the intelligent application deployed at the edge. The complete end-to-end system is currently integrated and are deployed in Taiwan. Yeah. Up next is the system workflow. So in the beginning of the mission, the bus, via the OCS orchestrator, will be responsible to instantiate the EFS application. In this case, the one marked in the green box. There are 4 of them. All of them will be managed by the bus to deploy and instantiate it. After the instantiation is completed, the drone will be able to start publishing the drone data to the edge via the 5G communication, where it will be received by the DAS to perform data preprocessing as well as storage. After that, The Eagle Eye or the EFS application will be responsible to consume the pre-processed data and start performing inferencing and insight gathering based on the received data. During the inferencing process, the telemetry data from the EFS application will also be published to the DAS for storage, in which this can be used by the bus later on to perform SLA enforcement or maybe horizontal scaling if needed. Up next is the visualizer. This is where the output of the Eagle Stitch as well as Eagle Eye or any other EFS application visualized in a visual way to the end user. The data from the Eagle Eye module specifically will also be forwarded to the drone navigation server. This is the navigation server that is responsible to perform automatic trajectory update during the mission to update the waypoints of the drones that are currently deployed on the field. With that said, we're gonna talk more about the deployment of the EFS application with the bus. As a vertical, by utilizing the bus, the vertical service will only need to upload the vertical service descriptor to the bus. With this, the vertical will be able to perform automatic deployment of the application that they want to run and for the mission. In our case, we can see that we prepare a descriptor file containing the information on how we want the application to be deployed by the bus. In this case, we have 4 of them to be deployed. We just upload the vertical services descriptor to the bus, and then it'll perform the deployment of vertical services automatically to the edge infrastructure. In this case, it will be deployed and spread over the 2 racks of the edge data center. With that, we're also gonna follow up with the connectivity mapping. This is how we plan to connect all of those components, physical components together at the edge to do the mission. In the left-hand side, we can see that we have the 5G small cell, the G-Node B, which is directly connected via fiber link to the edge data center, in which the servers is spread over 2 racks. The server will be responsible to host the modules that will be running or the application that will be running for the mission. All of these components are also currently fully integrated and connected at the edge. The next one is the disaster relief mission scenario. I'm going to pass the floor to my colleague Samer to continue the presentation. Samer?
Yeah, sure. Thank you, Tim, for the rich presentation. But let me first, before we go to the details about the disaster relief mission, to recap about 3 points. The first point, for our disaster relief, we have the 5G connectivity, and we already use the 5G non-standalone solution. And this solution, all of the component is already integrated and in the building of MIRC building in the National Jarton University. And the second one, we are doing the computing in 2 parts. One part is in the drone itself, and usually it's the fog computing and edge computing, which is we have edge data center where we have like more processing and like object detection, especially the Eagle Eye will be processed over there, and also the Eagle stitching. The third one, which I want to emphasize over here, we have the 5G-DIVE components, and this is including the intelligence, automation, and so on. So we will go through all of this and in our demo scenario and the field, the trial, and show you how we are going to do it. So basically, the scenario starts with this, like we have a person in the MIRC building, a person waving a flag for, needing for help. The public agency, fire department, and so on get this request, and or for something like earthquake or something like this. Of course, they will send the drones to do the scouting and to find the person need for help. So the way we are going to do it, the drone 1 and 2, we assume they are going to do the zigzag around the building till they find the person need for help. Meanwhile, we are doing this. All of the video streaming will come from the drone to the edge data center, where the processing and response will send back to the drones, or it will send to another direction. The second step over here, we are not referring only for the person need for help. Also, we are doing the 2D stitching. We are doing this to help, especially for disaster area. Maybe the image is not clear. The public agency, the fire department, for example, when they are reaching to the position, they don't really understand what is the current situation. So the 2D stitching, it will be kind of quick and will help the fire department to give the action quickly to the area of the mission. The third point, which we want to mention over here, the drone number 3 mainly is doing the stitching in our scenario, but when the person need for help already been detected, the GPS location, or if we want to gather more information, it will send to the navigation data center at the edge, and it will send an automatic order for the drone number 3 to fly and gather more information. Let's go into more detail and show you how this is happening. So here is a demo for you. We take it from our field trials. So the drone will fly over here. The operator, they are running the drones. So it will start doing the zigzag, flying around the building, trying to capture the images for the, so we can see the person need for help waving the flag over here. So this is very helpful, like the detection will find this person and send the images back. Now we start getting into the results. Next slide, please. So we already have initial results. Initially, we start with the 4G connectivity, and we find especially the most critical part for our mission disaster relief is the uplink, because we really need to stream more videos and more sensor data from the location back to the edge to do the processing. So we can see that the uplink is almost 83 megabit per second, and this can support multiple drones. But if we just use the 4G network, it's only 20 megabit per second, especially we are using high definition images. It will be not enough to support more drones. So the first thing with our initial result, we can see that 5G connectivity really is supporting and helping the mission for the disaster relief. And of course, latency and the downlink information, both 4G and 5G is sufficient, but the uplink, we still need the 5G connectivity. Next slide, please. Okay, now moving to the edge, as my colleague already mentioned, we have the Eagle Eye, and the Eagle Eye consists of multiple components, and we establish it as multiple component. This is will help like to save more drones, because if we just have one component and trying to do the processing for all of the drones, it will be really time consuming and it will not be efficient. So we can see like Eagle Eye have the data offloader, dual object detection, person need for help candidate selection, and then the sorter, and finally the validation. So of course, in the end, we have the visualizer, and visualizer is really very important, especially for the mission operator. Beside this, we can see the eagle stitching, and eagle stitching, we just based on like there is one drone, so we don't really need to consider to divide the component to multiple components, because it will be enough to do it with one drone. Going to the initial results we have over here, the processing latency we found is around 40 milliseconds, and this is really good enough for the mission. It's enough to send the images back to the edge, do the processing, and come back to the mission. Besides this eagle stitching, we find getting like 4 input images, we need around 1.2 seconds to process this and really get the images. And next, I will show you one result of the eagle stitching and also some result of eagle eye. Finally, the drone to edge transmission, we found the average pre-processing time is around 32 milliseconds, and the transmission latency around 20 8 milliseconds. And I think this is good enough for our mission. Finally, the bandwidth consumption per image is around 1.1 megabyte. Next slide, please. So here we show you like the view. We can get it from the drone itself on the left side, and in the right side we can see after detection. You can see how the visualizer will show the person need for help. So you can see the blue box, and we test this actually outdoor and also indoor, like in the upper side and those. And we think the result was really useful enough. Still, we are in the middle of our field campaign. We are still doing more testing and more result, and maybe in the future, please stay tuned if you want to get more results. Next slide, please. So this is just the initial results of the eagle stitching. Very quickly, we get these images from around the building, and this image, like, it can help the people for need, the operator, especially to understand what is the situation, especially if the building is in damage or something like this. We really need to understand this, and this will help them not only to use the drones to go quickly for the mission disaster relief, also they can see maybe calling for more operator or more fire departments to come and help them to the location need for help. Next slide, please. With this, actually, we come to our conclusion. We already have shown that we have the end-to-end deployment. This is starting from the UE at the drone, going all of the way to the EPC, because we are using the 5G non-standalone. Of course, we are using EPC over here. So this is all of the traffic coming over there. And also, we didn't show it over here, but it's really important to mention. We have the IMAC, and this IMAC, especially if the core network is far away, we can do the traffic breakout. So the traffic doesn't really need to go all of the way to the core network. It can be steer trafficking, and we can go to the application wherever it's located. So over here, it was located at the edge. Finally, we have seen that the PAS and the DAS and ISS really enhance the overall performance for our system, and this is really very important. And one conclusion, very important, we get like the deployment automation is really very important in this system, because it really takes a long time to do the initialization or preparing the drones to fly. So if we have like a new drone, we already have the PAS now, can help us to deploy the infrastructure needed for the drone, and then he can stream all of the traffic back to the edge and do the related access. The last word I want to mention over here, this is one of our main use cases. We have also the drone collision avoidance use case. And if you want to get more information, please visit our website, and thank you. Thank you for listening, and any question, please go ahead.
Thanks, Amr. Thanks, Timothy, for the very good presentation. So any questions from the audience?
Yeah, there would be some questions from my side once again. Thank you very much. Very interesting presentation. As we also working on drones, one question I would have is, what kind of drones are you using? Do you have some self-developed drones, or did you use some commercial product with some computing facility on board?
Actually, one of our third-party partner in the project is a drone company. They they buy the drone ready, but they do like a lot of upgrade for it and so on. For example, they start mainly like the drone navigation server. It was just streaming all of the traffic back and supporting one drone, but right now they already develop it, and they continue to develop their software, and they can support as much as drone you want in their navigation server. They already did this thing up to 50 drone, and they changed, like in the beginning, it was big CBE, but right now it's very small UE, like a dongle. So they are still in the processing of the development, and we can share the information for you if you like.
Okay, yeah, it would be really interesting. So you basically, that means you have quite a powerful computing engine on the drone itself to support this, probably some kind of Linux system or something like that, I would guess.
Yeah, but we try for the image processing, the detection, we try to do it at the edge, because not concerning the computing, concerning the battery lifetime of the drone, actually. This is our main goal. But still, like in the future, this is possible, actually.
Okay. I mean, our experience is more that basically the engines, the motors, drain the battery much more than the computing stuff. Yeah.
Yes.
Go ahead. Please.
Yeah, we have the Jetson Nano actually right now at the drone, so I think it's good enough. But I don't know in the future we have something more powerful than Jetson Nano. Yeah, but right now I think it's good enough for computing of the drone.
Okay. And did the drones fly autonomously, or were they kind of manually controlled?
Yeah, actually, this use case, mainly the drone 1 and drone 2, we just give them the route, and the drone number 3, like we will fly autonomously. But our first use case, actually, we call drone collision avoidance. You can see the autonomous effect, because it's really very important for the safety, and you cannot, I think you have seen this, it's not easy just to let the drone fly by itself. You have a lot of concerns and
I know. We made lots of experiments with collision avoidance, with multiple drones flying and basically meeting in a single point and try to avoid collisions and stuff like that. Yeah, that's why I'm curious about if you have some digital twins or something like that, so where you could basically kind of test everything beforehand in a virtual environment or things like that.
Yes, yeah. We did we have a simulator, actually. We did this. Our company, they have the simulator. They did this beforehand, because you cannot just go fly, because it's very risky.
Yeah, I know, especially if you have guys that like this agile programming style of programming. Yes. Yeah, that's right. Okay. In your simulator, do you also mix the digital world and the real world? I mean, for example, what we did is basically we kind of tested the collision between drones, and by that one of the drones were flying in reality, and the other 3 drones were simulated. So basically, the real drone was kind of feeling that there were colliding drones and kind of getting around this. Yeah, but the other drones were not really there not physically, just virtually. Yeah. So this allowed us to really nicely test the thing without having a big risk that they really collide. So basically, you can just look into this, what happens, and then basically after you are done with your experiment, you can see what is their actual distance and stuff like that.
Yeah, actually, this is very interesting idea, but mainly what we have, like in our real field trial, we make like when it on stationary or flying at low altitude, and the other drone flying in high altitude, and then they're supposed to collide. And then, because we didn't go to the collision avoidance directly, actually, they are flying at altitude, and then we are safe even if they are colliding.
Okay, you try to keep it separate. Yeah, fully understand it.
In the beginning,
makes sense as well.
Yeah, when we feel it's good enough after enough field trial, we let them fly at the same height, altitude.
Okay. Thank you very much.
Sure.
Thank you very much also for the question. So for the sake of the agenda time, I think we should switch to the next session, which is going to be chaired by Joseph. So please, Joseph, go ahead.
Okay, good morning, everybody. My name is José Manguez. I am researcher at CDDC, a research center in Barcelona, and I'm the communication dissemination and exploitation leader in 5GROWTH. And I have the honor of chairing session 2, which is in the experience from operators and vendors. So we've seen how verticals can use this technology. Now we are getting a bit closer to the technology, the underlying one. And we have 2 interesting presentations. The initial one will be given by Conde Schepper, who has been more than 10 years at Nokia Bell Labs, and he's currently leading the Access Network Control Research Department. And he's been deeply involved in aspects on exploitation related with patenting in particular and many others. So his talk is mission critical, latency, or throughput. So Kun, floor is yours.
Okay, thank you. Let me share the slides. I hope you can hear me.
Yes.
Yes.
Yep. And you can see the slides in the meantime. So good morning,
Yes.
and thanks for the invitation to present here in this workshop. So as a 5GROWTH partner, the role of Nokia Bell Labs was mainly to work on the innovations, research innovations. So in data plane innovations, more specifically programmable data planes to facilitate new innovations. Also in AI/ML for more the orchestration, network orchestration, and then where possible, we also want to show our results in testbeds and in pilots. So this presentation will be mainly about a data plane innovation, let's say, that we worked on, and more specifically the challenges of consistently providing low latency at very high throughputs. So if you need to remotely control large industrial equipment, of course, it is very important to be prepared for the unexpected. So you always have to have a plan B and preferably have a graceful degradation for it. So typical, if communication and especially wireless communication can always be broken, so there needs to be fail-safe mechanisms implemented, emergency stops, then deadman switches. If you remotely control, it's like a deadman switch. You cannot control it anymore. You have to switch to autonomous mode to park in a safe position, etc. So it's well known by the industry how to do these things. Our focus is more on can we, instead of have an on-off behavior, not more work on a graceful degradation for remote control. So how do we let users stay in control, the driver stay in control, the remote driver, under constrained resource availability? So looking a bit more into how typically today remote control SLAs are built up. They have a latency bound and a throughput guarantee. And if there is not enough resources in worst case, or there are problems, what should we sacrifice first? Will it be latency or throughput? So looking a bit more in detail about latency. So small latency only, meaning there is throughput enough, but latency varies, are usually acceptable. Depends how you define small, of course, and experienced in a kind of graceful way by humans, as long as they are small enough. Large latency SLA violations are usually caused by throughput violations. Anyway, if you have to build up a latency, it is always because there is a time where there is not enough throughput, and vice versa. Also, if you violate your throughput, then that typically causes very large latency buildups before where the bottleneck is, where the throughput is reduced. So throughput is key. That's more or less the clue or the conclusion. So what if there is not if there are not enough resources? If you cannot guarantee this throughput, so it's clearly very important that you at all time have this throughput. But of course, there are limitations to a system, physical limitations. What do we do? Well, the only way for a graceful reduction or a graceful, let's say, solution is to ask the application to use less throughput. And this has to be very, very fast and on time. And that's why it's important to have a technology that is capable of working in band, even at real time, to control these throughput variations, let's say. So we have worked also on L4S in the past. And L4S, just a quick introduction for you. It means 4 L's and an S. The 4 L's are from low queuing latency, low packet loss, and for scalable congestion controls. So L4S, the goal is to have no queuing latency, or it's possible to achieve no queuing latency at all, to have no packet loss at all. And the scalable congestion controls is mainly because you might have heard the current congestion control in the internet is not scaling up to higher throughputs. So there needs to be a kind of correction, an improvement to make future congestion controls scale for the more and more higher throughputs we can use on the internet. And today, actually, we can't use them as good as they should be usable. So L4S is based on 40 years of internet congestion control experience. Let's say we know what went wrong, what went good, what went wrong. So it's reusing all the existing protocols, but improved the behavior with the lessons learned mainly from data center technology. The internet was very hard to change because you cannot change over one day the mechanisms which are based to let everybody collaborate. In a data center, you can they regularly deploy greenfield, everything together new, so they could change all the things at the same time, and that there has been a lot of lessons learned related to especially low latency. And this would be nice if you could use this on the internet. So what we did, we made it compatible with the internet, all these new technologies. At the end, there are more details to it, of course, but you could say by just applying a square. If you want to know more about this, there is a lot of information available. Maybe a bit of features of L4S. It is a real-time in-band protocol. It only needs 2 bits in the IP header. There is no need for applications to use any control plane APIs. Of course, they can for additional features, but basically there is no need. And it's using the IP header as a kind of meeting point between applications and the network. That's the communication channel, which is universally available. So it is, at the end, a universal technology. It is, let's say, link technology independent. It works for 5G, it works for Wi-Fi, it works for Ethernet. You can use it in any technology. And it's proven to scale to billions of users because it's based on the experience we have on the internet. It's the core of the internet, why we don't have an internet collapse, a congestion collapse. So, and the scalability here is maybe a little bit different than the scalability for the congestion controls with the throughput. The scalability here means that it can work on a single flow, on a single application, but it also can work on an aggregate of applications. So if you have a lot of application flows running in a network pipe, it can control, let's say, the throughput of all these applications without knowing the individual applications even. So it can work on a global scale or on a very fine-grained scale. It's up to the capabilities of the network device. So we have implemented this technology and tried it out in this case we had the opportunity to show it, actually showcase it in the port of Zeebrugge. So there we have a 5G standalone network where we could demonstrate remote control of such a straddler crane. So it's a crane which can pick up containers, tag them. It's a 13-meter high device. It's nice to have a 360-degree camera attached here. And we don't really remote control the crane yet, but we remote control the viewpoint of this 360-degree camera. So to show you what we did is actually, you see here a smartphone which was connected to the 5G network. We made an application where the finger movements, you can look around from such a driving crane. And what happens is actually that the finger movements are sent to a processing device which is near this camera. And it converts the finger movements, which a viewpoint actually, where you can zoom and pan, into a normal high definition video. And this high definition video is sent to this application. So it's avoiding that you have to send this massive, very high footprint data over your wireless network. But of course, it is very important that you have very interactive low latency communication. Here we just watch around, but if you have to control the crane, it's as important that this is very smooth and you get a crisp reaction. Okay. Here we show a few, so in here you see again this application where the finger movements are shown by dots. I hope it's coming through very smooth over Teams. I have the impression it works well. But this, if not, this here on my screen shows as a very smooth experience. You can watch around, zoom in, zoom out. And typically here, for instance, our application you see is using around 20 megabits. The latency is about, the network latency about 15 milliseconds. The frame delay end to end is about 30, 40 milliseconds. And so it gives a very smooth experience. The SLA is, we need at least 25 megabits per second, and the application in this case uses 20, so there is definitely a good user experience. So we have a high video resolution and a full remote feeling of remote control for the user. Here I'm going to show you what happens if this application is not informed, but the SLA is degraded and we only have 15 megabits per second available without the use of alpha-res in this case. So what happens is that the video slows down, the responsiveness is delayed, and the application limits in a certain amount the delay. It will skip frames in best case. Sometimes if it's completely, depending on the network SLA, it will freeze, build up an infinite delay, and even might crash. But in any case, if no special treatment is done, the user loses control. So what happens if we degrade the SLA even further? In here, the more it is degraded, the worse it works, the more unstable everything becomes. So in here, even if we reduce it to 7 megabits per second and we use alpha-res, you will see that there is a slight reduced video resolution. But I guess you can't see that even. It's even hard to see for me what's the difference, but there is a lower resolution because that's how the application adapts. We tell it, okay, you should use less bandwidth, so it can reduce the bandwidth and the coding, but it can keep the low latency and fully remote control experience. Maybe just to inform you here, this latency stays around 10-15 milliseconds, even below. And the frame rate, the frame latency is similar like in the other case, but we only use this 5, 6, 7 megabits, where here the latency goes up to seconds, and yeah, we are limited to the 15 megabits per second. So that's exactly what's happening. Even going further, if we really make it really bad, like 0.5 megabit per second, we can show you the difference between not using L4S and using L4S. Without L4S, it's very simple. The video stops, applications often crash, there is a total loss of control, and like I said before, this emergency stop mechanism must be triggered. If you use L4S and we reduce the link speeds also to below 0.5 megabit, I'm going to show you the video here. It's now still about the 7 megabit, and it's going to be reducing. Sorry. Do have to press this button. So you'll see that, hopefully you see that if the latency is reduced, the throughput is reduced, the latency still stays around this 15 milliseconds, 10 milliseconds. And it's like having bad weather conditions, but the user keeps full remote control. You see again here, we go to lower latency, the video stays smooth. Okay, it's more blocky, but I would be able to drive remotely a car by this. I would be more careful, like if there is bad weather conditions. The advantage is also we can zoom in to see more details because we encode after we zoom. So it's not, if we would have sent the whole video, it would be reduced a lot, and the full footage would be bad quality, let's say, and zooming in wouldn't help. So that's also an advantage of controlling at the source. Okay, this is what we did as one of the innovations, and hopefully this can improve the usability also of 5G and improves the confidence in the technology, so that there are ways to improve and to make reliable, let's say, remote control. Thank you for your attention, and if you have questions, just ask.
Thanks a lot, Koen, for your interesting presentation. Are there questions from the audience? Yeah, there seems to be one. You can directly activate. Yeah, please.
Thank you, Josep. Yes, one question from my side. So how does L4S compete with the other flows in the network? I mean, it's clear the beneficial impact on the flow of interest, but what about the other flows that could be in the network? Is there any implication, impact, bad impact, or something like that?
Yeah, that's a very good question, and actually this technology allows to kind of put policies on which flows do you want to impact. So certain applications can adapt, other applications might not be able to adapt. So you might choose which applications needs priority. So it is not, well, actually, there is a bigger impact to other applications if you give it a very high priority and cannot adapt the throughput, because you use massive amount of resource if your channel conditions are bad. And it might be better for your other applications that you, even with your high priority application, because you're remotely controlling a vehicle, to reduce its bandwidth and also the resources it uses, the energy efficiency might be reasons to do this. There are many reasons why you would want to, let's say, control the rate of even your highest priority traffic. In the other case, yeah, you just have to meet the SLA, and if it's a top priority, you will actually starve potentially all other applications. Does that answer your question?
Yes, thank you.
Thank you.
Thank you, Luis Kuhn. Any other question from the audience?
Yes, so Bengt Dahlgren here from RISE. So my question is, what support do you need from the network regarding managing these 2 bits that you need in the packets?
So from the network, well, it's obviously it needs to have some intelligence, some policies. It has to support policies where you have to clearly make the decisions which how am I going to balance all these throughputs, and at the end, if you have a decision on what is a throughput and hopefully a real-time decision, you can build it in at real time in the data plane. It's just a matter of marking the packets and keeping marking the packets until the application adapts to the rate that you want. And typical mechanisms are token bucket mechanisms. So you control the rate, and whatever, if you're above the rate, packets get marked. And that's it, actually. There is also impact in the applications, because you cannot do that on any application. There is clearly the need to collaborate between the network and the applications, and the applications also have to receive those marks, look at the IP header, the ECN bits, the explicit congestion notification bits, feed it back to the sender. And there in the sender, of course, the sender needs to reduce its throughput until the level of marks is again to a certain target. So all of this is defined, and
so you need to monitor all the queues in the network, basically.
You can do it based on the queues, indeed, or on other information. Even energy efficiency could be used if you want certain energy level not to be exceeded, or whatever. It's for everything, you could say it.
Okay, thank you.
Thank you.
Okay, so thanks again, Koen. Thanks a lot for your interesting presentation. And let's now switch to the second one, which comes from the 5G-DIVE project. So in this case, it's Chengwang Lu, who's been at Ericsson Research since 2008. He's currently master researcher there and involved in vision from whole interface design and edge computing for IoT. And he also has a quite nice view about exploitation, since he's been involved in patenting and many other related activities. So he's gonna give you a nice overview of the exploitation opportunities out of the 5G-DIVE project. So Chengwang, please.
Yes, you can hear me, right?
Yes. Yeah.
Okay, good. You see my screen?
Yes.
Okay, perfect. So I'm the innovation manager in 5G-DIVE project. So I hereby present a summary about 5G-DIVE innovations and exploitation. Basically, these are the highlights. So, and basically, I will present first the design of 5G-DIVE deep platform. That is DIVE elastic edge platform. So this is some kind of plug-in platform to an edge system. So secondly, I will basically present the system integration with deep, how different use cases can be integrated into the deep. And in this part, then we have 2 points. One is the deep integration, and the second part is SLA management. And in this project, we have developed five proof of concept test beds, and also we have done 6 demos. Basically, within these 5 POCs, then we have 3 for industry 4.0 use cases, and then we have 2 for the autonomous drone scouting use cases. And then these 2 actually have been presented before in this workshop by our colleagues from NCTU and E-Tree. So I will not spend much time on that because you have seen the details. So first, so it's the design of the 5G-DIVE deep platform. So and this is basically a plug-in platform to the underlying edge computing infrastructure. So you need to have an edge computing infrastructure, for example, based on some kind of orchestration system like Kubernetes or 5G and many others maybe. And then you provide this kind of deep platform on top of that. Then that will basically have three parts. One is the bus, and second is the DAS. Third is the IESS. The bus is for business automation. So basically, that provides this lifecycle management of the services and applications, and also provide a user interface to the operators of the system, of the edge system. Then that basically facilitate the management task and reduce the knowledge required from the operators. And then that will do service orchestration and coordination, SLA management, and that will also provide this active monitoring capability that can monitor the service quality and the resource utilization, for example. It also supports the external federation, so basically federate with another edge system. The DAS is called the Data Analytics Support Stratum. That provides services like data storage, data pre-processing for machine learning, and also the data dispatching. The third bullet, the third part is the IESS. It's that Intelligent Engine Support Stratum, and that provides basically support to the edge computing system with machine learning and AI capabilities. So that does the AI and ML model management, and also can perform the model training. So, and they are connected with some of the interfaces which are defined in 5G-DIVE. Okay, so with the deep platform, then you have to integrate basically with different use case or application or different systems. So then they are deployed differently. So then each system will have a orchestrator. So that could be Kubernetes. And then another use case may have another orchestrator that is, for example, based on 405. So then the system, for example, the bus system that will do the lifecycle management, then that need to support different kind of orchestration ecosystem. So, and then these orchestrator drivers are developed in the bus, and that basically that support then that make the use case actually easier to deploy, because then they don't have to stick into one orchestration framework, but they can actually have a flexibility to do to choose their own. So and then we have a dashboard, and that dashboard actually provides the interface to the operator to manage, basically to have the visualization of all these management tools. So, and then basically we have the business translator then translate this kind of a service requirement to to some kind of a more technical metrics than the vertical service manager will operate on. And then we have the SLA manager try to guarantee the SLA quality, basically. And then we have IESS, and then that one basically have IESS catalog, and then that basically stores all the customized training models. And then we have also intelligent engines that provide the training services. And for each use case, basically you have this IES inference apps, so you will basically get the models, and then you do the inferences. So basically using the model, and then you have the application and the services to be augmented with the IESS app. So this is basically how this can be flexibly support different kind of use cases or different kind of even existing developed apps. So And also one use case actually can use two orchestrators if especially when it if there are two types of computing resources, like you can deploy also the functions and applications to constrained devices, and then you maybe not it's not good to use Kubernetes, and then you should use more fog related orchestration framework like 5GROWTH. So then if you have more powerful edge resources, then you probably want to use Kubernetes. So then, but in this framework, then we can support them flexibly. And this is about SLA management framework we have adopted, and basically then we have a hierarchical definition with SLA. Then we have the top SLA definition. Is some kind of a example. It's like you have a gold, silver synchronization, or you have the different availability level. So then that is very abstracted, and then which does not need so much the technical details, and then basically then you have SLA objectives. So you have this is one SLA objective, so this is another SLA objectives. Then you can combine them together so to form SLA agreement, and then you have basically then you go down that. Then for each SLO, then you have this SLI, that's the service level indicator. Then you have more technical definitions. Then you have to make sure that is for example less than 10 milliseconds, or whatever. Basically, then this framework things, then we have this activity monitoring as subsystem. Then we can create some kind of closed loop that will automate this SLA management to manage the resources. For example, if the SLA cannot do, then we should upscale with more resources, for example. Then for Industry 4.0, then we have designed this 5G SLA trial system. Then it's based on the Ericsson radio dot system. So basically we have a baseband unit, then we have this indoor radio unit, then we have the radio dot deployed basically in the field, and then this is the Ethernet cables. Then we have two of those dots, and then they are combined cells, so it's one cell. Then we have the 5G SA CPE on the other side, and that basically that provide the connectivity to the two use cases or two POCs. And on the other side, on the base station side, we also have a UPF server that will do this local breakout, and our FGC control plane actually it is remotely in Sweden. So yeah, basically this is our and we have in the test we see actually uplink we can get 115 megabit per second, and then in downlink we get around 700 megabit per second. So that should be enough for basically for this deployment for these two use cases. And also the latency is the maximum latency measured so far, that is below 25 millisecond. That is very good latency with 5G, much better than 4G. So then this is the first POC in the Industry 4.0, that is a digital twin. And then basically the digital twin stack, these are the innovation points, and the digital twin stack design over fog devices. That is basically the robot, and then the edge and the fog. In the edge, then there's some kind of the edge control system, and also the cloud, working together with the cloud for training, for example, of the machine learning and the AI models. And then we have also the DAS integration, and that will publish that is used for robot sensor network to publish robot sensor data. So and then we have a low latency remote control in the digital twin system over 5G. So then you can see basically then the digital twin. Then when you move the joystick, then basically the digital part and the physical part, they are synchronized. And there is also resource pooling for potential resource savings when you have multiple robots running at the same time. And then, basically these POC provides this understanding on the radio network impact to the digital twin systems. Yeah. And second part is about the zero defect manufacturing. So, and basically then there's a conveyor belt. Then we have some kind of products going on, and in the production line, then you basically there's a video camera that will detect if there's a defect or not. If there's a defect, then the robot will basically take this off the production line. So and in this one, then we have developed AI-based object detection that is adapted to the latency requirements, considering both cloud and edge and the constrained edge or fog, basically fog devices. So then there are the telemetry data from UE and network computing nodes exposed to an AWS-based data lake. So then basically that's cloud, edge, and fog. They were working together form this kind of a continuum. And the data framework for enabling intelligent run applications. So then they can do this multi-access basically between the 5G and Wi-Fi, that then aggregate or switch between the the traffic between 5G and Wi-Fi. And the third POC in the industry for the series is called massive MTC, and in this one then we have done a cloud native design for massive MTC. So we have an end-to-end testbed. Basically, we push the PHY and the Mac layer implementation into the edge instead of on the node, on the gateway itself. But we have this instead. We have a radio head deployed that is smaller, and then we have an end-to-end testbed based on IEEE 802.15.4. And that's basically shows that we have the high layer network functions resource pooling possibility. There we have basically we can share the Mac layer. So then that can save the resources in the edge. And then we have also the IQ data exposure. Basically from the radio head, we can expose the IQ data, not really high level data, it's low level data. And then to the IESS, then there we have RF fingerprinting security services. Basically, we can detect if this device is original device or not. If it's a fake device, then this can be detected and the service can be terminated. And then this one use the deep learning framework for the detection. And then then secondly, we have a large emulation testbed based on LoRa and also at IEEE 802.15.4. So basically here we have this we developed a packet generator to emulate a big number of cells. So then we could play with this emulation testbed and see the auto scaling effect. Basically, then we can see actually then we can pool the resources to serve a lot of cells when the traffic is not high. So especially for massive MTC case, the traffic is always is normally not congested. So of course, if with high traffic, then we will scale basically scale in the having more, for example, to have a horizontal auto scaling to have more resources to serve more and more traffic. But then when the traffic is low, then that should be also scaled out. Then release more and more resources to other services. Then we have this, yeah, exactly as I talked. Okay, we have the resource orchestration and service auto scaling of all these functions. Basically, we are using Kubernetes in this case. Okay, then for ADS case, I think then the one is the dual fleet navigation. These have been presented in this workshop before. So they have done this real field measurement, and it looks really nice. So you have seen, I think, like half hour before. And also the second one is intelligent image processing. Then they use the edge resources to do the image detection, and then basically fly the drones to the to the people that needs help. Basically, all these actually use cases are integrated into one 5G-DIVE system. So then we have one edge system that can basically host all these applications, and also the bus provides the lifecycle management of all these different services. So then that would make the operators job, the management job, much easier. So you have like one system to control everything. So and also it's in a abstracted way. So basically that concludes my presentation.
Okay, thanks a lot, Cheng-Huang, for your presentation and the overview of the potentially exploitable use cases that you have developed in DIVE. Really interesting. So is there any question from the audience?
Hi, Josep. I can ask a question.
Okay, please go ahead.
And Cheng-Huang is going to enjoy this. From a vendor point of view, what do you think is the key innovation of 5G-DIVE? What do you think you can get into your production?
Yeah, this is a hard question, right? We are from research part of Ericsson, so yeah, I need to think a bit about this question. I mean, the thing is, okay, the first, the knowledge we have learned from this is a lot. Especially we have basically made this 5G system for 5G-DIVE. Then we understand actually the use case requirement, and we are confident now that 5G can do that. But you mean the innovations? I think this. A 5G-DIVE deep platform that provides a good reference that we probably can learn from for our systems. For example, on the IESS part, provide such services. Yeah, I think so far that is also the in our use case, this massive IoT, massive MTC use case. I think this one. It has potential actually to be further developed from the product development. Of course, that is a product decision, so it's hard to say.
Thank you, Antonio. Thank you, Cheng-Huang. Any additional question from the audience?
I have a question.
Yes.
What CPEs did you use in your?
We use ASCII CPE. I don't remember the model name. It's RL3030. So it's a big CPE, I would say.
What's the brand?
ASCII from Taiwan. So
okay.
ASCII, I think, do we have? Yeah, this one, ASCII.
Yeah, it's a.
Okay, thanks.
But we are also using some 5G hats on top of Raspberry Pi that we are working on right now. Okay, so it's a mix. For the most professional stuff, we use the ASCII one, and for more research-oriented, where you can modify things, we are using the Raspberry Pi hats.
With what modems? With
the
what
modem
modems?
Is this Qualcomm. I don't remember in my mind. Basically, that's this Qualcomm one supporting SA.
Cycom, Quectel.
I think it's the Qualcomm chipset.
Yeah, it's in the Raspberry Pi hat has a Qualcomm chipset.
It's a Qualcomm chipset that supports the SA. I think that is only one chipset we. Yeah, but anyway, I don't remember it in my brain now.
Okay, thank you.
Okay, thanks. Any other question? I have one, Cheng-Huang, for you, which is I mean, Antonio asked specifically about that dive result. Let me ask a more generic question. So maybe Kun can join also. It's based on your experience in European projects, which is quite wide. So which one do you think is the most promising exploitation approach for operators and vendors in the framework of EU projects? So based on your experience, which one you think is the one that delivers more results towards products and services that make it to the market?
Well, I think for myself, it's the open source. If we develop some open source software, I think that is the most valuable from exploitation or from this kind of adaptation industry of the adaptation point of view. Basically, if it's open source and with a friendly license, I think that is very good. Actually, that can accelerate adaptation from the industries. Of course, the patents the companies always do, but that is more that is also useful. But I still like more the open source development.
Okay, thanks a lot. Any last minute question before we break from the audience? Okay, so thanks a lot, Chenghuan. Thanks, Kun. So this concludes session 2, and now we have a 10-minute break, right? So we meet again at 10:55. Thanks.
Okay, Antonio, with 1 minute.
Paola, I understand you are controlling the slides, so who is controlling the slides?
Sorry?
Who is controlling the slides?
You can control the slide.
I can? Okay. And how do I do that?
Just share in the row, share content.
Okay, so each speaker will share the slides. Okay.
Yeah.
Okay, thank you. Okay, so shall we wait some more time, or is okay if we start?
I'm here, Antonio.
Hi, Gada. Nice hearing you. Okay, I think we should start in order to be in line with the agenda. So thank you all for the quick coffee, and we are going to continue with the session focused on SMEs. So right now, sorry, 1 second, allow me to stop the Skype because I'm hearing a lot of pings here. Okay, sorry for that. So our next slot in the agenda is focused on SMEs, that, as we know, is one of the key focus of the European Union, the European Commission, in order to improve the exploitation of results of research projects. So in order to explore how 5GROWTH and 5G-DIVE are impacting the SMEs and opening new markets and so on, we have 2 speakers involved in SME companies. So we have first Giada Landi from Nexus, and second we will have Matteo Pergolasi from Telcaria. So we will start with Giada Landi. Giada is a project manager and researcher at Nexus, that is a small company located in Pisa that is currently involved in a lot of different European projects and internal research projects. And she's going to present us and give us an overview on what is the view of this very involved SME in the European research of how SMEs can exploit these results and how can innovate in the SME arena. So Giada, thanks a lot, and you can go ahead and present. As Paola was explaining, you can share your slides.
Okay, perfect. Thanks, Antonio.
Thank you very much.
Can you see my screen?
We can see your screen. We can see your screen. Your camera quality is very bad, so maybe it's worth if you just disconnect it.
Yeah, maybe the network is not working very well.
Exactly.
Okay, I apologize for that. But anyway, so today I'm basically going to present our view on how SMEs that are involved in the ICT area and in particular in the 5G sector can benefit from the participation to a European project, a European research project, and how they can exploit this experience in the market and in the context of different activities, especially in terms of potential relationships with the vertical industries. So first of all, a quick look at what Nexus is a quite common profile for SMEs active in this area. So we were established in 2002. We are based in Pisa, in Tuscany, in Italy. Actually, our core team has a lot of experience in ICT, telecommunication, control, automation, and basically our main asset is really the know-how and the skills of our employees. This is why we are quite convinced that for us it's mandatory to invest in research, in innovation, and we have nearly 20% of our expenditure that are targeting the R&D activities. We also think that it's quite important to cooperate with the research projects in Europe, even beyond Europe. This is one of our key assets, actually. This is our vision in terms of technology. So what we are focusing on at the moment, 5G, as you can see, is in the center of our overall view. Of course, now 5G, and we are moving beyond 5G towards 6G. And as we can see here, there are a number of areas and sectors that are quite related to these technologies: cloud, edge, NFV, SDN, big data, Internet of Things. And all these items are somehow correlated to 5G networks, and it's fundamental for us to provide full, complete solutions that are helping our customers in all these different sectors to be more competitive on the market. So again, the focus on the research. The focus on the research is fundamental for us because we really need to be up to the latest updates in terms of technologies. The research activities in the context of a European project is bringing us more closer to the potential market, to the potential customers, and it's also a very good way to understand the real requirements coming from the field. We are active in the 5G PPP area, starting from the phase 1, where we basically started with the research of the foundations of 5G. We started with the very old, right now, cross-sole and self-net projects. And then we moved towards all the different phases of the 5G PPP project. So going to research, results, and consolidation in terms of also implementation of technologies, to move then to the real experience on field, right? So to the work with the verticals, the testing of our solutions, the trials with real vertical services. And this is where our experience with 5GROWTH is basically placed. It's not enough, of course. We are also moving beyond 5G, as I mentioned before, and we are going towards 6G, and this is why we are also participating now in the XSX project. So it's a continuous cycle, as you can see from here. So starting from the initial design of the foundation technologies, let's say, we have moved to the development of concrete tools. Well, in our particular case, our focus is on 5G control and orchestration. For example, we developed the network slice controllers, the design of end-to-end 5G facilities for the trials, then the customizations for real verticals, and in this context also mechanisms to measure the 5G KPIs. We had experience with several vertical industries, of course, using the cooperation with multiple European projects, as you can see here. Some of the targets were on automotive, energy and utilities, manufacturing, media, and so on. And another aspect that is really important for us as an SME is the full alignment and the cooperation also with the standards. For example, we had experience with ETSI, ETSI NFV and ETSI MEC. Let me say that for an SME, usually it's quite complex, right, to reach the standards and to be really involved in the standardization effort. And this is one of the aspects where the participation in European project can really help, because we have the opportunity to collaborate with different kinds of companies, academia partners that help to also reach the standards and to be more competitive on the market, because it's fundamental to propose products that at the end can cooperate with existing system and that are easy to integrate with the current deployments. So let's now move to the role of Nexus in 5GROW, where we act as actually as technology providers. So we have been involved in the design and development of the vertical slicer, that is a critical component in the overall 5G management system, since it's basically the entity that translates the intent from the vertical, so the definition of the vertical services, into the network slice profiles. In this sense, the experience, the practical experience with the vertical has helped a lot to understand the real requirements coming from their perspective, and to also understand the gap that there is currently between the kind of expertise from the verticals that is very service and application oriented, and the complexity that is beyond a 5G network, a management system of the 5G network, 5G infrastructure, and so on. And so the vertical slicer is actually the component that tries to fill this gap, provides a number of functionalities, internal functionalities, for example, for the smart arbitration of concurrent vertical services, for the translation between the service requirements and the network slice profile. It can also embed some logic for the sharing of the network slices, also introducing some AI-driven technologies. And another particular aspect that is covered in 5GROW that is becoming even more relevant in the latest years is the integration between public and non-public networks. This is quite critical to reach specific use cases, for example, in the Industry 4.0 sector. It's also important to note that the implementation of the vertical slicer has been based on an open source development. As also mentioned before by Chen Wang, and I fully agree with this, the open source approach allows to reach a wider audience, allows to facilitate the adoption of the proposed solutions in several areas, and simplify somehow the collaboration with external partners. And for an SME, this is quite fundamental, because it also helps to reach potential customers and to achieve a greater visibility in the market. So just a very quick overview of the vertical slicer. I'm not going to focus too much on that. I would just like to highlight some of the key aspects of this component, in particular in terms of customization. Since wherever there is the possibility to develop custom components that are basically tailored on the customer's requirements, then there is space for the SME to propose their own solutions. This is important because SMEs are usually very agile in the potential development of novel technologies and in the integration of specific solutions that can be customized for different kinds of requirements. So as you can see here, this is a very modular component that can integrate external arbitrators, for example, using AI and ML techniques, that can integrate vertical-oriented blueprints that can be designed specifically for different verticals, that can support the interaction with different components proposed by different vendors or in the open source community, for example, in terms of network slice management functions or in terms of NFV orchestrators. At the same time, again, it's fundamental to be compliant with the standards, because this is the key of the interoperability of our system with existing deployments and future deployments. So again, the slicer has been designed as a modular component that can be integrated with several custom features. And this is where the participation in several European projects is actually helping us to identify requirements in this sense, but also to develop and introduce initial solutions that then can be exploited in the context of our consultancy activities for specific customers, or even to propose our own products. Why not? So in this sense, the slicer has been used in various research projects in the context of Horizon 2020, but also in the context of some ESA programs, so the European Space Agency. Here I've just mentioned some of the functions and features that we have introduced during our participation to the various projects. So for example, the multi-domain and the edge computing, the possibility to integrate public and non-public networks, the introduction of the satellite network in the 5G access and 5G backhaul, the possibility to use the AI/ML algorithms for closed loop control at the different layers, so in terms of vertical service management, but also in terms of network slice sharing and network slice lifecycle management. The possibility to integrate optical transport networks, the possibility to manage different kinds of 5G core networks, both open source and proprietary, the possibility to integrate the control of the radio access network, for example, using the Open RAN RIC, and so on. And finally, also the possibility to experiment the system with real, concrete 5G vertical services, for example, in the context of 5GROWTH, but also with 5G or Vital 5G, where we are creating basically experimentation platforms. And then not only 5G, now we need to look at the future towards 6G, and so the full cloud native paradigm, the continuum of the far edge, edge and cloud, the enhanced closed loop control, and even more the usage of edge AI. So, of course, this is becoming a part of our software stack. We call that the Nexus 5G NFV stack, where you can see basically the positioning of Sebastian, of the vertical slicer. This is the name that we have given to our software, together with the other components that we are developing in Nexus. So, for example, the NFV orchestrator, the plug-and-play control plane for different network slices, the 5G apps and service catalog, the SDK that allows to translate, let's say, between the vertical services models and the NFV standards models. So this is part of an entire system, let's say, that allows to provide a complete end-to-end solution for 5G. Again, the possibility to work in the European projects is also giving us the possibility to increase the visibility of our system. This is just an example of participation in NETSI and IPOC, where we have worked with other partners, for example, in this case with the UC3M, to propose an end-to-end solution that integrates several components, including also our vertical slicer. So in this sense, we can say that there are strong business opportunities for the SMEs as technology provider for 5G solutions. And here the key is the customization, right? So there is a possibility, for example, to propose orchestrators that are able to integrate specific data plane technologies, or to manage the 5G network slices in a very service-driven approach, or to enhance the resource orchestration and management, for example, using AI techniques, or somehow propose custom deployments for standalone non-public networks. This will be important, for example, for verticals in the industry for the zero area. And in this particular case, we can also evaluate the possibility to integrate open source components, for example, open source orchestrators, or RAN-based solutions for the RAN, open source 5G core networks, and so on. And in this sense, the major roles could be as system integrators, as third-party software providers, or in the consultancy market, again, as software developers, as technical project managers, and so on. And then there is the other aspect that is equally important, that is the support to the verticals in the 5G environments. We worked on this area in several projects, and we had the possibility, the opportunity to address several requirements from very different sectors, industry, for example, automotive, health, smart cities, transport and logistics, and so on. Some lessons learned here. Important to note the variety of the requirements. So when addressing one specific vertical, we need to focus on some kind of services, and they could be completely different from the services in different sectors. And also the target KPIs are completely different, and also the deployment models that could be more suitable for a given sector could be quite different from the ones in different sectors. So, for example, the standalone non-public networks are only applicable in some specific cases, but we cannot extend them, for example, to entire 5G cities, right? Then the other point is that there is a strong gap between the vertical service-oriented know-how and the complexity of the 5G networks. And here is where NSMEs with strong expertise on 5G can help. For example, it's quite difficult for a vertical that is just approaching the 5G market to identify the real benefits of 5G technologies and how is it possible to fully exploit them. In most of the cases, services for 5G, so 5G-enabled services, requires a sort of re-engineering towards a full cloud native approach. And it will be also important to make applications more network aware. And then the other point, the link between the network KPIs, the service KPIs, and the business KPIs is not always very clear. So this is where we could help the verticals to understand how they could benefit from 5G networks and how they can propose solutions that are really aligned to 5G and that can exploit its capabilities. And in these areas, we identified some specific topics like security, edge computing, AI, where we really think that there could be strong opportunities for custom and added value solutions that NSMEs like ours can propose. So just some very high-level examples of experience with verticals. So, for example, Industry 4.0 in 5G and also in 5GROWTH. So as you can see here, the focus of the verticals is basically on their own services, right? But the 5G network is much more complicated, and it's up to us to help them to fill this gap between the verticals know-how and the 5G network complexity. And in this sense, for SMEs involved in 5G, there is the possibility to be active in the consultancy market, for example, for system integrations for 5G deployments, again, to propose a custom version of standalone non-public networks. This can be applied to Industry 4.0, Smart Campus, Smart Agriculture, and so on. And there is a lot of interest also on the integration with the specialized solutions that are currently available in the vertical premises, for example, so in terms of edge computing, IoT platform, TSN networks, and so on. Then also the possibility to act as third-party software developers in particular for the development of 5G-enabled vertical applications in specific sectors, and the possibility also to customize and tune the vertical services coming from the verticals, providing a support that goes from the design to the testing phases. And also the possibility to review together with our customers the design and the modeling of these services for virtualization purposes, for cloud native patterns, the decomposition between edge and cloud, the integration of 5G and edge services, for example, for network analytics, localization, and so on. And then finally, also the possibility to evolve our own company product portfolio, for example, in the sector of smart yachting, smart building, smart factory, where we could actually bring also the 5G network awareness in order to improve our products. That's all from my side. If there are questions, I will be more than happy to reply.
Thanks a lot, Giada. Let me see if there is any raised hand. Doesn't look like. Guys, if someone has a question for Giada, now is the moment.
Hi, is she?
Hi.
Hi, thanks. Yeah, thanks a lot for the great presentation, Giada. Maybe I have a question regarding, you mentioned there's a big gap between the vertical on the services for requirement for 5G or 6G, and then there's the 5G deployment. So what exactly, I mean, the gap, more specifically, will be lying in what kind of aspects, and what would be the key solution you are going to bring to fill this gap?
Yeah, so basically the point of view of the vertical is mostly focused on the service requirements. So they have a very clear view about what they would like to propose in terms of application solutions, but then how these applications should be designed, let's say, to make a full use of all the capabilities that a 5G network can offer, then this is somehow less clear. So, for example, let's think about the network slices, right? There is a strong opportunity here in customize the network slices for meeting the requirements of specific applications. At the same time, 5G networks are also able to provide services, for example, in terms of localization or in terms of network data analytics that can be reused by the application in order to provide added value services. Or even more, the cloud native approach for the decomposition of the vertical services across the edge, the cloud, and now with 6G, also the far edge, right? All these aspects are not very clear for the vertical, simply because it's not their job. And so in this sense, there is a double opportunity. So the first one is to provide tools and software components like the vertical slicer that helps in an automated way to fill this gap. The other point, from an exploitation point of view, let's say, is also to propose the SMEs as potential supporters, let's say, of the verticals, to help them in understanding the features that can be offered by the 5G network, and somehow to also tune their own services and to steer somehow also the implementation of their applications in this sense.
Yeah, thank you. I think it's quite clear now. So it's meaning how you can integrate some of the 5G functions, which your vertical does not even aware, or it's not their job, as you say, and how you can integrate this to fulfill their services and application. And one of the ways you do in the vertical slicer to compose such a network slice, including both vertical function plus the 5G related network functions.
Exactly.
And Yeah. So that's I think the major contribution from the vertical slicer component. And then you mentioned the SNE. I think I fully agree. That's the important role. That's the to be as a consultant role to bring such expertise to the vertical to fill the gap on to give more opportunity or like catalog of services which they can consider.
Yeah. Thanks, Shi.
Thank you. Thanks, Jada.
Okay. Thank you very much, Giada. Giada, thanks a lot. We don't have time for more questions. Very appreciated your presentation. Thanks a lot. Guys,
Thank you for the opportunity.
Thank you, Giada. Before moving into the next presentation, just one reminder, we are doing a survey on the quality of this workshop, okay? You can find the link to the form in the chat. Please go ahead and fill it because it's very useful for us in order to improve next sessions of this kind of workshops, okay? So thank you very much. Our next speaker is going to be Matteo Pergolesi. Pergolesi, sorry, Matteo, I always say it wrong.
No worries.
Basically, Matteo is working in the company Telcaria, that is also an SME here in Madrid, in Spain. And he's a researcher inside this company, and he's going to present us how can we use the edge and AI, and how can we adapt this concept to the 5G-DIVE platform in order to assess the different vertical requirements and to answer to them. Okay, so thank you very much. Matteo, the floor is on your side.
Okay. Thank you, Antonio, and good morning to everybody. Thank you for having me. So in this presentation, I'm going to talk about a bit our experience in 5G-DIVE and about trying to ease the adoption of edge and AI technologies for verticals. So we are going through, oops, it doesn't, okay. We're going through some motivation for our work with other partners in this project, 5G-DIVE, and what solution we came up with that is a platform to try to unify the edge and provide advanced features. And from here, as Telcaria, we thought during these months about new business opportunities that can sparkle from these kind of solutions. And so I'm going to present to you a bit these kind of ideas that we have, and what are the advantages for SMEs and verticals. Finally, we're going quickly through a demo of this platform that we developed in 5G-DIVE, and we draft conclusions and future perspectives. So, as I believe it was already mentioned some here and there in this workshop, from a point of view of available platforms for computing in general, and especially for new technologies or new paradigms and architectures, there are many platforms available, and they all have their specific concepts, their specific design, and so on, going from cloud providers to edge platforms, both from standardization organization like Etsy or open source, and up to more advanced platforms for high-level applications like machine learning and artificial intelligence, where now we are seeing a trend where these kind of things are getting more and more automated through very complex platforms that can provide very advanced features. Well, the thing is that for a vertical, this is a very hard word to move around. So it's hard to decide what kind of platform you need for your specific use case. It's even harder than to try to integrate two or more of these platforms, because each platform provides its own features, and to have a full stack of technologies that serves all your needs, you need, of course, to integrate several of them. And then there is also an additional effort, because you need effort to orchestrate this platform, manage these platforms. And so you need people, you need knowledge, you need time, okay, spent to understand the concepts and understand often the very specific details of the technologies that you
managed to select. So we believe, and this is a bit of something that we learned inside the 5G-DIVE project, that this scenario, this world that we live in, it still constitutes a high barrier for verticals to enable advanced features, especially at the edge, so on locally and distributed resources. So in the project, we came up with this idea of having a platform that can unify many vertical premises, many kind of technologies, many platforms, and provide a unified interface for the verticals to interact with their resources. As my colleague Cheng Wan presented before, well, my partner, sorry, we have developed, designed and developed this deep platform, that is the DIVE Edge platform, that is built on common concepts that are common and simple, and they can be applied to many of the platforms that I showed to you in the previous slide. They call the things with different names, but at the end we can abstract them and put them in the same bucket of common concepts. The DIVE platform is modular to provide several features in a separate way with a well modularized design. We have the business analytics support stratum that takes care of the automation of the management and the lifecycle management of your services. We have the intelligence engines support stratum that provides automated AI and machine learning as a service. And then we have the data analytics support stratum that offers services for data dispatching and data processing. So from this kind of simple idea and design, we believe that we can define a new business model, especially for SMEs. So if the SMEs has some kind of relationship with a vertical, and the vertical nowadays, when they are involved with technologies, they always have some kind of premises that can be embedded devices, computing resources, or networking resources. Well, we see us as an SME to propose to these verticals that already collaborate with us, or new clients, let's say, we can propose the license to access the service, the advanced services of the DIP. And with this kind of business model, we can directly integrate the vertical premises of our client through a remote instance of the DIP platform. So we don't need to actually deploy the platform on their premises. We just need to create the proper interface and proper connectivity in order for the vertical to access and use their resources through the vertical premises. In this way, the vertical has immediately access to all the advanced features of the DIP platform and can start immediately work on the application that they care about, so the domain-specific application, and then do not need to deal with the complex technicalities of the platforms below. There are, we believe, many advantages, especially for the SMEs, because you increase a lot your efficiency with this kind of model, because you actually do not have to build a giant centralized cluster of the resources to offer to your client. You can reuse the resources that your client already have, applying advanced features, and you can integrate these features very quickly. So you can start working with your vertical, with your client on their application, their domain-specific application in days instead of months. Furthermore, you can centralize the management and the support for your verticals, because they all access to the resources through a unified interface. Of course, there is an accounting system that allows for separation of each vertical to access only the interface they own, the premises that they own. But for you as an SME, you have a single system to deal with, and a single system that and a single language, let's say, that you can use to support your verticals in their issues or problems. Furthermore, you also mitigate the risk of single point of failure, because the DIP adds advanced features to the services of the vertical, but the services of the vertical keep running on their local resources at the edge. So if the dip goes down, it's true that you lose these advanced features, but it's not a hard failure because the services can still keep running on the local premises of the vertical. One thing that we believe is important is also that the SME does not need to manage data and workloads directly on its premises. So the datasets and workloads stay in the vertical's premises, and the SME does not need to implement complex privacy policies that can then that are hard to manage and so on. And from this simple business model that I just presented to you, more business model can also sparkle, because the SME in this case become some kind of intermediary between many verticals that are doing innovations. So the SME can act as a kind of broker that can, for example, propose the federation of resources of different verticals and propose some kind of collaboration or resource leasing. So creating new business models between the verticals themselves. So we believe this kind of model really opens a lot of opportunities for SMEs nowadays. Then what are the advantages for verticals? Well, for example, the vertical can avoid complexity because the deep, as I said, is built on simple and understandable concepts that are common to many platforms that are available nowadays. And they can delegate the orchestration of resources and the management to the platform so that they can cut costs in the sense of for the administration of their resources. Furthermore, they immediately access to advanced features that can optimize the management and the usage of their resources. So the vertical can have access immediately to production-ready technologies for the management and orchestration, as well for machine learning and AI. And also it immediately has access and integration to best practices in order to optimally manage their resources. As we already said for the SME, another important aspect is that the vertical can keep all its data at home. So the workloads and the datasets never leave the perimeter that the vertical set. And this is very important nowadays for data privacy, and the vertical in this way does not have to rely on a external cloud provider to manage their data with concerns about privacy, security, and so on. And last but not least, for the vertical, this integration with the deep platform, it means to unlock innovation, because they can immediately start focusing on their domain-specific application and integrate the features, the advanced feature of the deep platform with their application, like, for example, as I said, artificial intelligence as a service, as provided by the IESS, the Intelligence Engines Stratum, the scalability for their services to enable better performance or enable reliability, and more stuff that comes out of the box. Okay, now I have a quick demo of a deployment of a vertical service on the deep platform. So this is the main interface of the system. We have, of course, an accounting system, and right now I can show you that here we are. Oops, sorry, I didn't want that. Really sorry. There is this overlay here. Really sorry about that. But I just wanted to say that, as you can see here, we are managing many vertical regions. So we are managing more resources from verticals that are distributed potentially across the world. Now, here we are creating the description of a vertical service. This is a model that we designed in 5G-DIVE project that is abstract enough to be applied to many edge platforms. And as you can see here, we are now loading the service inside the deep platform. So it's the deep takes care of preparing all the resources. In this case, we are deploying on Kubernetes. As you can see, in a matter of seconds, the service is already starting, and the platform provides us a public port in order to access the application. This is a web application made of this web interface, a database that, as you can see, the application has already connected correctly. And so in a matter of seconds, we deployed a standard legacy web application with our platform. Okay, I also have another demo. This is about, sorry, but it's not switching. Okay, this one. This is an application showing how we can deploy a service with artificial intelligence and machine learning functionalities. So as you can see, we are creating this service as we did before, so with a very similar descriptor. So even if the application is very different from the one that we deployed before, we are reusing a bit the same concept here. And for deploying this machine learning application, we only have defined the kind of problem that we want to solve, and we are passing our platform a dataset in order to implement the whole pipeline of the machine learning, the whole machine learning pipeline, that is training, testing, and then providing the prediction results. As you can see here, we first trained our model to solve the problem, and now we deployed the application to provide us with prediction results. The prediction results are provided through a REST interface, so that this is very easy for the vertical to integrate with their applications. And as you can see, we right now sent a request for a prediction. In this case, this application is classifying animals. And by not writing a machine learning algorithm, not dealing with cleaning of data, selection of features, and so on, the system was able automatically to build a model for us that recognized that this animal that we asked for a classification was a mammal with the 99% of accuracy. So in the machine learning world, this automation trend is getting really, really powerful, and a lot of work that was done previously by data scientists is really getting automated and available for potentially everyone. So to draft quickly the conclusions, I believe that for us, Telcaria as an SME, 5G-DIVE really shed light on business opportunities that can be applied with the paradigm of edge computing. And we truly believe that nowadays, the technologies are mature enough in order for the SMEs to propose themselves as platform providers and compete finally with big tech cloud providers like Google, Amazon Web Services, and so on. And this is, as others have already said previously in the workshop, this is mostly thanks to the edge computing paradigm, but also thanks to open source technology that opened many opportunities and many tool reusability in order to achieve this kind of business model. And finally, the advantages are not just for the SMEs, but the verticals can also benefit of the features of a platform that has been designed with production software in mind and best practices. And while getting benefit for all these kind of features, they also keep control of their resources and their data. So they keep using the resources, they keep their data private and their workloads in the house. Thank you very much for your attention. And if you have any questions, I'm glad to address them.
Hello, Matteo.
Thank you very much, Matteo.
Sorry?
Paul Paixão speaking from FSEC.
Hi,
I have a question. Hi, Matteo. Thank you for the presentation. in FSEC, we are looking for this kind of platforms, software platforms to integrate our application in our services. But the question is that you said you can compete with the big cloud providers. How you can compete with them concerning the number of employees they have to support maintenance, to fix bugs, to have new functionalities, or for instance, to deal with the cybersecurity problems, because they have a lot of people working on that. So anytime I propose internally platforms like this, this is the question the board put to us and to discuss. And I think Microsoft or Oracle, they also provide this kind of services, and how you can compete with them.
Okay, so my first idea on why we nowadays the SMEs can compete with big tech companies is that thanks to edge computing, and so resources being distributed, resourcing being locally deployed close to the vertical. First of all, the SME does not need to deploy these giant clusters of resources where they host the services of their clients, of their verticals. And this takes off from the SME a lot of burden in terms of building the data center and buying buying buildings and so on to host the servers, manage all that, all those resources, connection, and so on. So I believe this is one advantage that the edge brought to us, and that allows SMEs to be a bit more competitive. And then for what concerns manpower, as you said, and the amount of time that people can allocate for security, for example, that is one very crucial aspect nowadays. Well, that's true that an SME cannot have the manpower of Google or Facebook for this kind of stuff. But at the same time, I believe that with a close collaboration with a vertical and a close coordination, I believe we can achieve acceptable results. And the main advantage is that the vertical does not need to bring their data somewhere else potentially in the world. So the data stay in the house, and the SME can help, first of all, the vertical getting knowledge about what security means, and then helping the vertical in applying stricter or better security policies so that they can manage the security inside the house, and so also enabling the full privacy on the data.
Okay. Thank you, Matteo.
Thank you.
Thank you very much, Matteo. Thank you for the question.
Thank you, Antonio.
Bengt, the floor is yours.
Yes, I'm Bengt Dahlgren. I host this last concluding panel open discussion. I'm a researcher at RISE, Research Institute of Sweden. I participate in the 5G-DIVE project, where I lead the work package on dissemination and exploitation. So first, I'd like to take the opportunity to thank the 6 speakers. Let us do a virtual hand clap here.
Thank you.
Then I prepared a few. So I think they presented gave very interesting talks indeed, covering complementary views on the research and results of the 5G-DIVE and 5GROWTH projects. So I have prepared a few items for discussion, but would first like to invite the audience with more questions and comments overall to the presenters and for discussion within the audience. So if you raise your hands, I can coordinate the discussion a little bit.
Yes, I can start. One big concern about the 5G technology, of course, we proved that the system works, but we have a big concern about the kind of service that the operators will provide in the future. Meaning security, meaning SLAs, meaning quality of service. Of course, we have slice in the technology, but the question is that how the operators will supply to the verticals the service they really need. Because big advantage of 5G technology is to use not a private network, but a public network, and this kind of service and the SLAs and quality of service must be dealt. And for the moment, we are asking all the providers, technology providers and operators, and the question is not answered for the moment. So if someone from the operators, for instance, Ericsson, can speak a little bit about this, it's very important to us.
So Chengguang, are you still with us? Possible for you to respond to that? Maybe I can complement that question with one of the items I thought about beforehand is that well, for all the verticals or the two verticals that were presented in this workshop, you depend on some 5G features, right? And I was curious to what is the most critical feature or performance issue for your vertical, for the application to work well. Or maybe it's not the communication, maybe it's the computation or the combination. So one thing that we heard from the disaster relief vertical is that the battery is one of the critical features. I don't know, Paolo, what your reaction to that is, and I'd like to invite Tim, if he's still with us, to respond to that.
Yes. No, for us, because I talk about the critical system, the availability is the most important issue. Availability and latency is the very most important issue for that. And but this answers to my first question: how can the operators provide this kind of services 24 hours a day and all the year, because it's a critical system?
See, do we have an operator with us?
We always have, but they are hiding. I think Luis is in the call. I'm not sure if he's available to answer. Luis Miguel, are you there?
It says on hold.
On hold. Then he's in another call. Okay, then nothing.
So Chengguang, again, are you there?
No, Chengguang left. Chengguang is not in the call. Looks like this time is lunch time in Sweden, so probably he ran.
Well.
No, but it's okay. It's also a present question for the verticals.
Well, we have people from Nokia, that's true. So maybe Nokia can answer.
Yes, this is Chai from Nokia. I'm the colleague for Kun. And yes, we're waiting for excellent answer. Yes, and I think what Kun will present today here is more on what the latency really plays a major role, even when the SLA cannot be matched. And of course, as Kun said that of course, not every, of course, can you hear me?
Yeah.
Yeah. Of course, not every application will really need, and this should be considered which kind of different application they need to coexist at the same time. So this is a solution we can provide it. But of course, as an overall solution for use cases, you need to consider, for example, that you have like EMBB, your ILC, your coexisted. So we have several solutions we provide in the 5GROWTH, like a virtual queue, and also the L4S presented in Kun's today's talk. We have showed up that can be really useful even when let's say the throughput cannot be matched. For instance, like Kun said that like driving in the bad weather condition, but we try to make a remote control still workable. So that is part of Nokia because we're more like a research Capital Labs. So we provide some research capabilities that could be let's say congestion control as the L4S solutions. So that can be part of Nokia, of course, Nokia's solution as a whole. So, but at the end, I think the question you asked is more related what kind of use case. Maybe Kun can address better that overall use case you want to provide it as a coexist at the same times.
Maybe it's also to clarify what is the question actually. Is it to the operators or to the vendors? Because you said operators. Of course, the vendors are not deploying the services. We can offer features, and as you see, we can do a lot. And it's important for the vendors at least to understand all the requirements and make it possible. Of course, operationally, I guess your concern is mainly operationally. Is there enough priority to handle issues very fast, actually, to solve issues? Of course, that's hard for us to talk about. There are other solutions as well. There is also a lot of interest in non-public networks, so that other kind of operators or even industries own their own 5G network. So it's a lot of, I guess it's a matter of giving the best service also for the vertical, which solution is the best and is sustainable in the future, and also depending on the criticality of your services that you might select rather one to another, also depending on how much money you want to spend on it as well, of course.
Yes, but I understand it's a question for operators, but the operators just can't provide the functionalities that the vendor supply.
You mean they can't they can't provide the functionality that the vendors or sorry, because
the functionalities, the functionalities comes from the vendors, and the operators adjust and configure the system according to the functionality, the available functionalities. That's the point. That's the point.
Yeah, that's definitely
because my understanding of 5G technology is the technology not for the consumers, but for the business to business service and applications, and it's what the business and the verticals are looking for.
So I think we have Luis with us now. If you want to post your questions to an operator.
Yes, again, apologies for. I think there was previously a question, but I was out for some minutes, so I couldn't take that. So,
if you quickly rephrase your question, Paolo.
Yes, I'm. Yes, the question is that. Okay, with this validation pilot and for the validation for the pilots that every other partners are providing, we can prove that the technology is available and ready to work with our systems. But this is a pilot, so the idea is how the operators and the vendors will work together in order to supply the quality of service and the vertical slicing and the proper configuration in order to have a public network or we still need a private network for this kind of services.
Mm-hmm. Thanks for the question. Clearly, I think it's maybe part of the story of the slicing, and so with the slicing, what we're intending is to tailor the network, right, to specific usages. So clearly, when we go in the direction of a specified of specialized services, we need to dig into the details and work together with the manufacturers for selecting and choosing the best breed technology for serving the purposes that are being demanded by the vertical, but also with the vertical for having a clear view of the need and tailor, let's say, the solution in this respect. Clearly, there will be specificities that will be very, let's say, local or very particular to a given vertical. Some others are probably much more generic. So for the generic ones, there will be easier to adapt to the multi-service networks that we have today. But once we go to specificities, we have seen today in the workshop these specificities in the several use cases in terms of latency, jitter, and so. Yeah, we need to team up with the rest of the stakeholders in the solution in order to clearly identify the point and tailor, let's say, also that part, to satisfy the case. Otherwise, would not be easy to address. Not sure, probably my answer was a little bit generic, but well, I think that.
Okay. Thank you very much. So let's try to cover another question here. So we have Xi from NEC raising a hand here. So please, Xi.
Hi, I raised my hand. I actually also want to comment on the previous question, but maybe very briefly. I think it's the operator has the role of glue everything. Also as Louis mentioned, the collaboration between operator and vendor is very important because like vendor from us like NEC, we can tackle like RAN or different kind of technology domain, and like Nokia, they may be working on the transport or the switch-based solutions. So this kind of all different technology need to be generalized and then need to be integrated by operator to provide all the solution for the vertical. And I think one of the key the operator can take is that based on, for example, what we developed in 5GROWTH platform, such or from 5G-DIVE, the deep platform, they are the management of for the operation management, and with how to ensure the latency or reliability or availability. It's like a domain specific, but at the end the KPI need to be fulfilled, and therefore the innovation is important. In this case, like the closed loop design, the AI machine learning is the key for such technology to enable this. But sure, it's a challenging and it's the path we have to take. So this is additional comment I would like to mention.
Thank you. So we are coming to an end of the workshop, unfortunately. So from the organizers and the 5GROWTH and 5G-DIVE projects, I'd like to thank everyone for participating in this workshop. So any final words from Paula or anyone else in the organizing team?
Yeah, I can. So I would like to thank to all for the participating, for a very interesting presentation and discussion. Clearly, we have some further point to go on because, and is a very relevant result because highlights that is a very key aspects that we have the opportunity also to consider the other discussion in our project. So. I would like to thank you again. I remind to fill the template for the link of the survey for satisfaction, and I think we can repeat a similar discussion internal to our project to go in deep in these topics. So thank you to all.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Thanks.
Bye-bye.
Thank you.
Bye-bye.
Thank you.
Bye. Thank you.
Bye.
Thank you.